Welcome YouTubers to another episode in my Grammar Hero series. In today's video, I'm going to be working out some practice problems that will closely mirror what you'll see in the Mathematics Knowledge Subtest of the Armed Services Vocational Aptitude Battery, as well as the Air Force Officer Qualification Test, that is the ASVAB as well as the AFOQT respectively. In order to get the most out of this video, I strongly encourage you to pause the video after I read each question, attempt to work out the question on your own scratch paper, and then resume playing the video to check your solution. In total, this video is going to include 25 practice questions, and in the description of this video, I'm going to have a timestamp that's associated with each question. Next to the timestamp, I'm going to include the topic that's being tested, as well as a link to a video where I discuss that topic in greater detail. So if at any point during this video you need more help, go ahead and check out those resources. And finally, I want to say that on both the ASVAB as well as the AFOQT, you're not permitted to use a calculator or a reference sheet. So as you take this practice test, try not to make use of any of those resources. So all that being said, let's go ahead and get started with today's video. All right, so this first question says -3 to the 5th power is equal to. To answer this one, we have to know how negative numbers interact with powers. Negative numbers raised to even powers result in positive numbers. Negative numbers raised to odd powers result in negative numbers. In this case, we have -3 raised to 5, which is an odd number. So we know our result, when we work this one out, is going to be negative. So right off the bat, I'm going to cross out these two answer choices that are positive. And in addition, we also have to know that -3 to the 5th is the same as -3 times itself 5 times. So that looks like this: -3 times -3 times -3 times -3 times -3. And by working this out, we'll figure out which of these is correct. So let's go ahead and get started. We have -3 times -3. Negative times a negative is a positive. 3 times 3 is 9. Okay, let's go ahead and multiply 9 by -3 now. Positive times a negative is going to result in a negative. Specifically, 9 times -3 is going to be -27. Let's go ahead and keep working this out. -27 times -3. We have a negative times a negative, so we know the result or product is going to be positive. And let's try to do this one in our head instead of working it off to the side. 7 times 3 is 21, so we would drop down a 1 and carry a 2. 2 times 3 is 6, plus that 2 we carried is 8. And so we know that -27 times -3 is +81. Let's go ahead and do one more iteration of this and we'll be done. We have +81 times -3. Again, a positive times a negative is going to be a negative. And we can do this one mentally pretty easily. 1 times 3 is 3. 8 times 3 is 24. So we can see -3 to the 5th is equivalent to -243 when you work it out. Okay, so that's that one. All right, number 2 says, what is the distance around a circular field that has a radius of 35 kilometers? Use 22/7 for pi. So on the ASVAB, unless it's specified, you're going to let pi be 3.14. In this case, they told you to use 22/7. So that's what we're going to have to use. Similarly, as we read this question, some information should jump right out at us, notably that we want to find the distance around a circular field. Well, the distance around a circle is found by the circumference formula, and there's two of them. Circumference equals pi times diameter if you have the diameter, or circumference equals 2 pi r, where r stands for radius. In this case, we were given the radius, so that's what we're going to use. We're going to use circumference equals 2 pi r. In place of r, we'll put 35 since we were told that's the radius. And in place of pi, we're going to put 22 over 7. So let's go ahead and keep working this one out. We have 2, and then we have 22 over 7 instead of pi, and then 35 for our radius. Let's go ahead and think about how we're going to solve this one. I know I can get rid of this 7 by multiplying 22 over 7 by 35. And let's do that off to the side. We have this 22 over 7 times 35. In order to multiply fractions with whole numbers, you place that whole number over 1 so that you write it as a fraction as well. So in this case, I can write 35 as a fraction by placing it over 1. And that's going to enable me to reduce this very quickly. Again, I know 7 goes into 7 one time, 7 goes into 35 5 times. So I'm going to divide 7 by 7 here, which is 1, and 35 by 7, which is 5. Now we have 22 over 1, which is the same as 22, as well as 5 over 1, which is the same as 5. Okay, so 22 over 7 times 35 is the same as 22 times 5. And if you can't do that mentally, you can do that math right off to the side as well. 5 times 2 is 10, carry your 1. 5 times 2 is 10, plus 1 is 11. So this becomes circumference equals 2 times 110. And if you can't do that mentally, you can work it off to the side as well. We have 110 times 2. 0 times 2 is 0. 1 times 2 is 2. 1 times 2 is 2. So we can see that this circumference is 220 kilometers, which is answer choice C in this case. Okay, so again, for the ASVAB, you're going to have to know the formula for circumference as well as area. For area, there's only one formula, notably pi r squared. For circumference, there's two formulas, pi times diameter or 2 pi r, which we used in this case. Okay, so that's that one. Number 3 says multiply 3/4 times 4/5 times 5/6 times 6/7 times 7/8 times 8/9. This is testing your ability to multiply fractions. And believe it or not, that's not that difficult to do. And let me start by writing this off to the side so I can have some room to work with. And we're doing 3/4 times 4/5 times 5/6 times 6/7 times 7/8 times 8/9. When you multiply fractions, you multiply straight across. That is to say, in this case, you would multiply all the numerators together. That is 3, 4, 5, 6, 7, and 8. And then you would place that over all of the denominators multiplied together, notably 4, 5, 6, 7, 8, and 9. So let's see what that looks like. In our numerator, we're going to have 3 times 4 times 5 times 6 times 7 times 8. And then in our denominator, we're going to have 4 times 5 times 6 times 7 times 8 times 9. Now, thankfully enough, this is pretty easy to reduce. We can reduce this 4 and this 4, this 5 and this 5, 6 and 6, 7 and 7, and 8 and 8. So this becomes 3 over 9. And as we can probably tell, both 3 and 9 have a common factor of 3. So to reduce this fraction further, we can divide it by a common factor of 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So we can see that this big long fraction all these fractions multiplied together result in 1/3, which is C. So not that difficult. Okay, so let's go ahead and move on to number 4. Number 4 says 3a over 2b divided by 6a over 5c can be reduced to. So in this case, we should realize that we're working with an expression of algebraic fractions. So we're going to reduce it by following the rules of algebra as well as fractions at the same time. To start, I'm simply going to copy this one off to the side like so. You have 3a over 2b divided by 6a over 5c. So the very first thing we want to do is address this division. When you divide fractions, you follow the algorithm KCF, which stands for keep, change, flip. That is, you keep this first fraction the same, so we're going to keep 3a over 2b the same. We're going to see or change the sign from division to multiplication. And then we're going to flip this second fraction. So instead of being 6a over 5c, it's going to be 5c over 6a. And as we've seen already in this video, now that we're multiplying fractions, we just multiply straight across. So this becomes 3a times 5c over 2b times 6a. Let's go ahead and see if we can reduce this fraction, algebraic fraction, any further. We can, since we have like terms of 3a and 6a. 3a can be divided by 3a one time, so that leaves us with 1 times 5c here. And 6a is divisible by 3a 2 times. That is to say, 6a divided by 3a is 2, and that leaves us with 2 times 2b in the denominator. Anything times 1 is itself, so 1 times 5c is just 5c, whereas 2 times 2b is 4b. So this algebraic fraction reduces to 5c over 4b, which we can see is letter choice C. Okay, so that's that one. All right, so number 5 says if 2x minus y equals -5 and y equals 1 minus 3x, then y equals. So it may not be obvious, but for this problem, we have to solve a system of equations. Specifically, we're trying to just solve for y. If it's helpful, and you can't see that we have a system of equations, you can write it off to the side like this. We have 2x minus y equals -5, and then we have y equals 1 minus 3x. Again, these are both linear equations since they have a y and an x, and everything's to the first power. That said, this bottom equation is not written in the same way that this top equation is. So the very first thing I'm going to do before I even talk about how to solve this system of equations is to take this 3x and move it over to this side of the equal sign so that it mirrors this top equation. So now we have 3x plus y. Again, this crosses out, equals 1. And then we're just going to copy over this top equation since we don't need to modify it at all. So we have 2x minus y equals -5. Okay, so now it should be obvious that we're working with a system of equations. And as such, there are two methods to solve a system of equations. You can either use the substitution method or the elimination method. As it happens, I like using the elimination method. So I'm going to multiply both this top equation as well as this bottom equation by two different constants such that they're going to enable me to eliminate this x variable. And if we think about it, we can multiply this top equation by a factor of a constant of -3, and we can likewise multiply this bottom equation by a constant of 2, and -3 times 2x is -6x, whereas 2 times 3x is 6x. -6x plus 6x eliminates the x variable. So let's see what that looks like. Again, we're taking this -3 and distributing it to everything in this top equation. So let's start doing that. We have -3 times 2x, which we know is -6x. Then we have -3 times -y. Negative times a negative is a positive. Therefore, -3 times -y is plus 3y. And then finally, we have -3 times -5, which is going to be positive 15. Let's do the same thing for this. Let me put that arrow there in case that's helpful. And then we're going to do the same thing with this bottom equation. 2 times 3x is 6x. 2 times y is 2y. And then 2 times 1 is just 2. Now we're going to add these two equations together. And as you'll see, we're going to eliminate this x variable in as much as -6x plus 6x is eliminated. This becomes 0, so I'm not going to write anything down here. 3y plus 2y is 5y, and 15 plus 2 is 17. Again, according to this problem, we want to just solve for the y variable. So to get y by itself here, we're just going to divide both sides by 5. This will cross out, leaving us with y equals 17 over 5, which can't be reduced given that 17 is a prime number. So our answer is y equals 17 over 5, which is C. Okay, so that's that one. All right, number 6 says the distance between 2, 4 and 5, 8, which are 2 points on a line, is most nearly. So in order to solve this one, we have to know the distance formula, and that's given by distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And you might be asking yourself, where do I get x1, x2, y1, and y2 from? Well, ordered pairs are always of the form xy. Let me give myself some space here. Therefore, I can label this 2x1, which would make this 4y1. And likewise, I can call this 5x2, which means this 8 is y2. So all we have to do to solve this one is plug these values into this equation and solve accordingly. Let's go ahead and do that. So x2, as we can see, is 5. This becomes 5 minus x1, which is 2. Again, that's squared. Plus y2 is 8 minus y1, which is 4. Of course, that's squared. Let's keep working this out. And I'm not going to skip any steps as I do this one. 5 minus 2 is 3, so this becomes 3 squared plus 8 minus 4 is 4. This is plus 4 squared. Let's keep working this out. 3 squared is 9, of course, and 4 squared is 16. 9 plus 16 is 25. Square root of 25 is 5. So in other words, the distance between the points 2, 4 and 5, 8 on a line, as given by the distance formula, is 5, which is D in this case. Okay, so that's that one. All right, number 7 says, what is the numerical value of 7 factorial divided by 5 factorial times 4 factorial? On the ASVAB, you may see questions involving factorials. Factorials just mean you take that number and you multiply it by all the numbers that are below it till you get to 1. So, in other words, 5 factorial, just to give you an example, is the same as 5 times 4 times 3 times 2 times 1. And by multiplying all these together, you'll have a numerical value for 5 factorial. Let's just do that for an example. 5 times 4 is 20. 20 times 3 is 6. 60. 60 times 2 is 120, 120 times 1 is 120. Okay, so 5 factorial, in other words, is the same as the numerical value 120. With that said, we have to do some operations with these factorials. So as is my wont, I'm going to start by copying down the problem on my scratch paper here. So again, we have 7 factorial in the numerator over 5 factorial times 4 factorial. The next thing I like to do is go ahead and expand these out. So 7 factorial, as we should now know, is 7 times 6 times 5 times 4 times 3 times 2 times 1 over 5 factorial. And I'm going to put these in parentheses just to make sure that it's clear that they're being multiplied together. So we have 5 factorial, which is the same as 5 times 4 times 3 times 2 times 1 times 4 factorial, which is the same as 4 times 3 times 2 times 1. All right, you might be saying to yourself, do I really have to multiply all this out? So when we worked with that series of fractions that were multiplied together, we crossed quite a few things out. And in this case, I'm going to cross out this 5, this 5, this 4, this 4, this 3, 2, and 1, which leaves me with this 7 times 6 in the numerator over 4 times 3 times 2 times 1 in the denominator. And this is pretty easy to do. We have 7 times 6, which is 42, over 4 times 3, which is 12, times 2, which is 24. 24 times 1 is just 24. And now the only thing we have to do is reduce this fraction. And as we should see, 42 and 24 have a common factor of 6. So in other words, we're going to divide both the numerator and denominator by that common factor of 6. 42 divided by 6 is 7, whereas 24 divided by 6 is 4. Okay, so let's see if 7/4 is one of our answer choices. And it looks like our answer choices are given as mixed numbers. Okay, so that's a little bit of a conundrum. We're going to have to convert this improper fraction and lie to that into a mixed number. And one way you can do that is to regard this fraction as division. You can read this as a fraction as 7 over 4, or you could read it as long division by saying 7 divided by 4. And by doing this long division here, you'll have your mixed number. 4 goes into 7 one time. 4 times 1 is 4. 7 minus 4 is 3. So in other words, 4 goes into 7 one time with a remainder of 3. Therefore, if we were to write this as our mixed number, this is our whole number. And then we take our remainder, which is 3, and we place it over the number by which we divide it. That'll be 4. So 7 over 4 is the same as 1 3/4. Let's hope that's there. It is. It's the second B, which should be D. So sorry about that. Sometimes making these videos, I do make some small errors when I write these questions. So this one is D, 1 3/4. Number 8 says, what is the volume of a cylinder that has a diameter of 10 inches and a height of 20 inches? So in case you don't know it, a cylinder kind of looks like this. You have a circular top, and a circular base. And according to this problem, we know the height of this cylinder is 20 inches, whereas its diameter is 10 inches. Diameter is the distance from one edge of a circle to the other edge of the circle and through the middle point. So in other words, the diameter of this circular face here is that distance right there. And we know that that is 10 inches. Okay, so for the ASVAB, you're going to have to memorize a few formulas for finding volume and surface area. I would recommend that at a minimum, you know how to find the volume and surface area of a rectangular prism as well as a cylinder. But thankfully enough, there's nothing really to memorize here. If you can find the area of a circle, you can find the volume of a cylinder very easily. Again, the area of a circle, as I may have mentioned in this video already, is pi r squared. The top of this cylinder is a circle. So to find the volume, which is all this space between this face and this face, we take the area of the circular face and multiply it by the height of the cylinder, and that's how you can find the volume of a cylinder. It's that easy. That said, we were given the diameter instead of the radius. In case it's not obvious, again, this is a top-down view of our cylinder here. We know the distance from here to here is 10. We want to figure out what the radius is, and the radius is always from the center point to one edge of the circle. The radius is always half the distance of the diameter. So if the diameter is 10, the radius is going to be 5. Okay, so in place of r, we'll put 5, and in place of height, we're going to put 20. Let's go ahead and work this math out. It's not too difficult. R is 5, so this is 5 squared times height, which is 20. Let's keep working this out. This is pi. 5 squared is the same as 5 times 5, which is 25 times 20. You should be able to do 25 times 20 mentally. Again, 20 times 20 would be 400, and that leaves you with 5 times 20 left. 5 times 20 is 100, so 100 plus 400 would be 500. Therefore, we know the volume of this cylinder is 500 pi cubed. Again, cubes always go with volume. Squares always go with surface area, so the answer to this one is A, 500 pi cubed. In case you needed me to work this out for you, just so you can see it, we have 25 times 20. And there's no problem working it out like this if you can't do the mental math. Sometimes I prefer working out simple problems just because I know if I'm tired, I'm prone to make mistakes. So this becomes 5 times 0, which is 0, 2 times 0, which is 0. When we start multiplication with this second term, we have to bring in a 0 placeholder. 5 times 2 is 10, so bring down a 0 and carry a 1. 2 times 2 is 4, plus 1 is 5. As you can see, we have 0 plus 500, which is just 500. Okay, so that's that one. Definitely memorize how to find the volume of a cylinder. I think I saw one of those problems on test day as well. All right, number 9 says, find the next term in the sequence. We have 3, 8, 18, 38, and 78. You will see a problem like this on the ASVAB. I have 2 videos on sequences, notably arithmetic and geometric sequences. That said, all you really have to do is look at these sequences until you discover the pattern that makes you go from one term to the other term. So let's see if we can look at these and figure out what that is. Let's go from 3 to 8. We add 5. Let's go from 8 to 18. You add 10. To go from 18 to 38, you add 20. To go from 38 to 78, you add 40. So as we can see, we're multiplying by 2 to get to the next term. 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is 40. So to get to this term right here, we're going to add 40 times 2, which is 80. So it's going to be 78 plus 80. 8 plus 0 is 8. 7 plus 8 is 15. So this next term is 158. Again, sometimes you'll get stuck on these. Just stare at them until you figure them out. There's no real other way to show you how to do them. Again, I can represent this sequence algebraically, but that's beyond the scope of this test. You just need to look to see the pattern. Once you find the pattern, find the next term. Okay, so that's that one. All right, number 10 says simplify the following expression and write the answer with only positive exponents. We have parentheses 2y to the fourth, v to the negative fifth, all raised to the negative second power. Okay, so as I usually do, I'm just going to copy this question down right here. We have 2w to the fourth, v to the negative fifth, all raised to the negative second. In order to solve this one, we're going to make use of the laws of exponents, notably the product rule to start. And the product rule says take everything in parentheses and multiply it by your exponent one by one. And if you don't see an exponent, it's implied that it's 1. So 2 is the same as 2 to the first. So what we're going to do right now is we're going to take all of our terms inside the parentheses and take their exponents and multiply it by this power outside the parentheses. Again, that's the product rule. So we're going to do 2, and then this is going to be 1 times negative 2. So I'll write that out for you. 1 times negative 2. Then we're going to do w, and this is going to be 4 times negative 2. And then we have v, and that's going to be negative 5 times negative 2. Let's go ahead and simplify these. This becomes 2. 1 times negative 2 is negative 2. We got w. 4 times negative 2 is negative 8. And then we have v. Negative 5 times negative 2 is 10. Okay, so we've went ahead and used the product rule to expand what's in parentheses here. And according to this problem, we could only use positive exponents. This is pretty easy to fix right here. When you have a negative exponent, if you bring it into the denominator of a fraction, it becomes positive. So let's go ahead and do that. Again, I want this exponent in 2 to the negative second power to be positive. So I'm simply going to bring it below this fraction bar, and that allows me to write it as 2 squared. Likewise, I want this w to the negative 8 to have a positive exponent, and by bringing it into the denominator here, I could write it as w to the 8th. And then since this v to the 10th is positive, we don't have to move it at all. We'll just place it in the numerator of this fraction bar. Let's go ahead and do one more thing. Let's expand 2 squared. Again, 2 squared is the same as 2 times 2, which is 4. So this is v to the 10th over 4w to the 8th, okay, which is a, as we can see. I do have a video that's about an hour long in which I discuss the laws of exponents. It's a pretty challenging concept. Most people don't see it until Algebra 2, if not later. So if you need help with this one, definitely check out my video on the laws of exponents. This isn't something that's taught in lower level algebra classes that often. Okay. Number 11 says, find the equation of the line that passes, and I'm blocking that. Number 11 says, find the equation of the line that passes through the point -2, 5, and has a slope of -4. So on the ASVAB, I guarantee you'll see a question in which you have to write the equation of a line given some values. And I have a video uploaded in which I discuss the 3 ways to write equations of lines. And in this case, I'm going to show you how to apply one of those methods. As you can see, we have 1 point on the line as well as the slope of the line. And because we have those 2 things, we can plug them into the point slope equation and just solve for y. And we'll have written our equation of the line. So the point slope equation says y minus y1 equals m, which stands for slope, times x minus x1. Where do you get x1 and y1 from? Well, again, those are our ordered pairs. This is x1, y1. And let me go ahead and write that off to the side since it's split up like that. We have -2 and 5. And this is going to be our x1 and our y1. And we're told the slope, our m, is -4. All we have to do is plug these values in where we see m, x1, and y1 respectively, solve for y, and we'll be done. So let's do that. We have y minus y1, which we identified as 5, equals m. M is -4 times x minus x1 is -2. Okay, let's go ahead and work this out. We have y minus 5, and I'm just going to fix this right here. We have x minus -2. That becomes positive. So this is -4x plus 2. Okay, so the next thing I'm going to do is take this 4 and distribute it to this x as well as this 2. So this becomes y minus 5 equals -4 times x is -4x. -4 times +2 is -8. Again, we want to get y, as we can see in our answer choices, by itself. So we're just going to add 5 to both sides. To do that, this crosses out over here, leaving you with just y on this side, minus 4x. -8 plus 5 is -3. So our equation of the line is y equals -4x minus 3, which is D in this case. Okay? You will see a question like this on the ASVAB, guaranteed. So make sure to know how to write the equation of a line if you're given 3 different things. All right, number 12 says, the sum of the interior angles of an octagon is. So for this one, you just have to know the formula to find the sum of the interior angles of any polygon, and that is sum equals 180 times n minus 2, where n refers to the number of sides in that polygon. In an octagon, we should know that there are 8 sides, so in place of n, we're going to put 8. So this becomes s equals 180 times 8 minus 2. S equals 180. 8 minus 2 is 6. And I'm going to work this one off to the side so I don't make any silly math mistakes. This is 180 times 6. 0 times 6 is 0. 8 times 6 is 48, so we're going to drop down an 8 and carry a 4. 1 times 6 is 6 plus 4 is 10. So we can see that the sum of the interior angles of an octagon is 1080 degrees, which is C. Okay, this is a very good formula to know. You might see it on the ASVAB, you might not. Sometimes they throw this question in there, sometimes they don't. All right, number 13 says, if a right triangle has legs that are 6 inches and 8 inches respectively, then what is the length of its hypotenuse? So for this one, especially if you haven't seen a right triangle in a while, it might be helpful to make a nice little diagram. Again, this is a right triangle, so we're going to denote its right angle with one of these symbols. And in a right triangle, you have 3 parts. You have 2 legs and a hypotenuse. The hypotenuse is always directly across from the right angle. So this right here, this side, is our hypotenuse. Similarly, using the Pythagorean Theorem, you can always find either the measure of a leg of a right triangle or the hypotenuse as long as you have 2 of those 3 things. So in this case, we have 2 legs, and in light of that, we can find the length of its hypotenuse. That said, the formula for the Pythagorean Theorem is a squared plus b squared equals c squared, where a and b refer to the legs of the right triangle and c refers to its hypotenuse. We're told that the legs are 6 and 8 inches respectively. So on our diagram, I'm just going to say a equals 6, and this is one of the legs, and b equals 8. That means this is C, and we want to solve for C. So let's plug in A and B accordingly and solve for C. Again, A is 6, so this becomes 6 squared plus 8 squared equals C squared. 6 squared is 36 plus 8 squared is 64 equals C squared. 36 and 64 is 100 equals C squared. Again, we want to get C by itself as it is over here. So we're going to get rid of that square by taking the square root of both sides. This crosses out, leaving you with just C on this side. Square root of 100 is 10. Therefore, we know 10, the hypotenuse, which is C, is 10. And so the answer to this one is B. You absolutely have to know the Pythagorean theorem for the ASVAB as well as the AFOQT. And more specifically, you have to know that if you're given A and B, you can find C. If you're given B and C, you can find A. And if you're given A and C, you can find B. As long as you have two pieces of the Pythagorean theorem, you can find the third doing some basic algebra. Okay, so that's that one. All right, number 14 says the Earth is 4,600,000,000 years old. Express the age of the Earth in scientific notation. So not surprisingly, to start, I'm going to copy down 4,600,000,000. We want to express this number in scientific notation. Scientific notation is always of this form. You take the number that you have and you place it with one decimal place like this. You multiply it by 10 and you raise it to some power. Large numbers are raised to positive powers. Small numbers are raised to negative powers. In order to figure out what this exponent to this 10 is going to be, we put our decimal place right here and we count how many times it takes to get to this decimal right here, which is right here in scientific notation. So let's count those places. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4,600,000,000 expressed in scientific notation is the same as 4.6 times 10 to the 9th, which is D. Okay, so that's that one. Again, I do have videos on scientific notation if you need a better explanation as to how to do that. All right, number 15 says express the expression square root of 5 plus 6 times the square root of 20 reduces to. So in this case, we're working with some radicals and we want to reduce this expression. Again, I'm going to start by copying this down. We have square root of 5 plus 6 times the square root of 20. I can't reduce the square root of 5 any further, so I'm just going to leave that as is. That said, I'm going to pull this 6 out to the side for a moment, and I'm going to think about how I could reduce this square root of 20. Again, we have square root of 20. 20 can be broken down to be 4 times 5, okay? And if we know our laws of radicals, we can now do this. We have a square root of 5 plus 6 times. We can break these apart such that we have the square root of 4 times the square root of 5 like that. And now it should be obvious that the square root of 4 is just 2. So let's go ahead and reduce that. We have 6 times square root of 4 is 2. So this is 2 square root 5. Let's just go ahead and multiply this 6 and this 2 now. So this becomes square root of 5 plus 12 square root 5. And now that these radicals are the same, notably we have radical 5 plus 12 radical 5. We can just add those together. Again, technically there's a 1 hanging out here, but it's not usually expressed. 1 radical 5 plus 12 radical 5 is 13 radical 5, which we can see is answer choice C. Okay, so that was that one. Key part of it was knowing that you can find two factors of 20, write them under the radical, and then break them into two separate radicals, which will enable you to simplify this expression further. Okay, so that's that one. All right, number 16 says the cube root of 729 is equal to. We're dealing with radicals again, and whenever you have a radical and there's no little number, index number written here, you always assume it's a 2. In this case, we want to find the cube root, so that's going to be 3. And of course, we want to find the cube root of 729. In other words, we want to find which of these numbers multiplied by themselves 3 times will equal 729. So I recommend that you memorize from 1 to 20 the squares and from 1 to 10 the cubes of numbers, because if you did that, you would realize that the answer to this is simply 9. Again, we're looking for a number such that we multiply it by itself 3 times, and that gives us 729. Let's go ahead and see what 9 does. 9 times 9 is 81. 81 times 9. We can do that mentally. You don't have to do it off to the side. 9 times 1 is 9. 8 times 9 is 72. So we know 9 cubed is 729. So the answer to this one is B. Okay, so that's that one. Let me move over a little bit so we can see what number we're on. Number 17 says simplify the expression. We have in parentheses 17 minus 6 divided by 2 plus 4 times 3. In order to solve this problem, we're going to have to make use of the order of operations, which is usually memorized by the mnemonic device. Please excuse my dear Aunt Sally. And that tells us the order in which we work out problems like this one. First, we work out what's in parentheses. After that, we scan our expression for exponents and take care of them, if there are any. Then we do multiplication and division as they appear in the expression from left to right. That is to say, they have equal precedence. And then finally, we do addition and subtraction as they appear in the expression from left to right. That is to say, they have equal precedence as well. So if we scan this expression, you can see that we do in fact have parentheses. So that's where we're going to start. And of course, I'm going to go ahead and copy this down to begin. So this is 17 minus 6 divided by 2 plus 4 times 3. Okay, so within parentheses, we're now going to follow the order of operations again. So we're inside our parentheses, and we want to see what comes first. So we're going to do 17 minus 6 first, or 6 divided by 2. Well, in parentheses, we have no exponents, but we have division, which comes before subtraction. So I'm going to start by doing this division first. So this is going to become 17 minus 6 divided by 2 is 3. Again, this is plus 4 times 3. Okay, we're still working in parentheses, and the only operation to carry out inside parentheses is 17 minus 3, which is going to be 14. Okay, so we only have one number in parentheses, so we don't have to use them. So this becomes 14 plus 4 times 3. Now we just have 2 operations left, notably addition here and multiplication here. If we look at our order of operations, we should see that multiplication comes before addition. So we're going to do 4 by 3 next. So this becomes 14 plus 4 by 3 is 12. And now we only have one operation left, notably 14 plus 12, which is 26. So the answer to this one is 26, and we had to use the order of operations to get there. Okay, so that's that one. Number 6 says factor the expression. We have 6x squared plus x minus 2. Let's go ahead and copy this one down. We have 6x squared plus x minus 2. This is a quadratic equation that has a leading coefficient, which is right here. That's something other than 1. So we're going to have to make use of the Australian method or AC method to factor this one quickly. Again, in case you forgot, quadratic equations are of this form: ax squared plus bx plus c. In other words, our 6 corresponds with a, and I'll write a right up here. Since there's nothing expressed in front of this x, we assume there's a 1. So this is b as our 1, and then c is -2. The Australian method says take a and multiply it by c. So ac equals 6 times -2, which is -12. Identify your b. B in this case is just 1. And we want to look for two factors of a and c that multiply to -12 but add to +1. So let's think about how we're going to do that. What about 4 and -3? 4 times -3 is -12, whereas 4 plus -3 is +1. So these are going to be our two factors that we're going to use. More specifically, we're going to take these two factors and we're going to replace this 1x with 4x and -3x. And we're going to do so such that it's going to set us up to factor this equation by grouping. So in other words, I'm going to stick the 3 with the 6 and the 4 with the 2. So let's go ahead and do that. Now I'm going to rewrite this as 6x squared. Again, I'm replacing this 1x with this 4 and this 3. So I'm going to put -3x plus 4x minus 2. Now we're going to factor this via grouping. Again, when you factor by grouping, you kind of imagine that this equation is split into two parts, notably 6x squared minus 3x and 4x minus 2. Let's pull out a common factor from this first part, and we should be able to see that we can pull out a 3x, which leaves us with 2x minus 1. And now we want to factor this second part of this equation such that what we get in parentheses is the same as what we have over here. So I'm going to factor out a 2, and that's going to leave me with 2x minus 1. As we can see, what's in parentheses is the same. Now we combine this 3x and 2x into one of our solutions, so that's going to be 3x plus 2. And then we just copy down one of the repeated factors up there, notably 2x minus 1. And this is this equation factored, 3x plus 2 and 2x minus 1, which is D. Okay, so that's that one. I do have a video in which I discuss how to factor quadratic equations in which the leading coefficient is something other than 1. Again, the Australian method, once you get the hang of it, makes solving these problems very quick and easy. Okay, so that's that one. All right, number 19 says the perimeter of a rectangular pool is 56 feet. If the length of the pool is 16 feet, find its width. Okay, so we're dealing with a nice, simple shape, notably a rectangle. We're told what its perimeter is, and I'm going to denote perimeter with a P. We're told that's 56 feet, and we know what the length of it is. Again, in a rectangle, you have a length here, and a width here, and a width here. To find perimeter of any shape, you simply add up all the sides. So the perimeter of this rectangle, in other words, would be W plus length plus W plus length. Okay? We know what the length of this rectangle is. We're told that the length is 16 feet. And since this is a rectangle, we know that this length is the same measurement of this length. So if this one's 16 feet, then this one's also 16 feet. And likewise, we know these two widths are equivalent as well. So let's go ahead and plug in what we have into this perimeter formula I just wrote here, and then solve for what we're missing. Again, we're told P equals 56. So in place of P here, I'm going to put 56. Likewise, we know what L is in this equation. L is 16. So this is W, which we're trying to figure out, plus 16 plus W plus 16. Let's go ahead and combine our like terms. We have 56 equals W plus W is 2W. 16 plus 16 is 32. Again, we're trying to solve for W at this point. So in other words, we want to get W by itself. So for my next step, I'm going to subtract both sides by 32, which will cross out over here, just leaving me with 2W over there. 56 minus 32, 6 minus 2 is 4, 5 minus 3 is 2. Divide both sides by 2 finally to get W by itself. We're left with W over here. 24 divided by 2 is 12, and in math, it's customary to write the variable for what you solved on the left, so this is W equals 12. Okay, so this one is W equal 12. Our width is 12 feet, which is C in this case. Okay, so that's that one. This is a pretty common question on the ASVAB. You'll be given the perimeter and a rectangle and either the length or width of that rectangle, and you'll have to find one that's missing. Okay, so you use some simple algebra techniques to do that. All right, so number 20 says, in a triangle, if the second angle is 2 times the first angle and the third angle is 3 times the first angle, find the measures of each angle of the triangle. Okay, so first of all, we have to know that all the measures in a triangle add up to 180. So in other words, one angle plus the second angle plus the third angle will always add up to 180 in a triangle. Let's go ahead and apply what information we're given in this problem to this generic formula here. So let's say the first angle is just the first angle, and let's call it x. According to this problem, we know the second angle is 2 times the first angle. So if the first angle is x, the second angle would be 2x. And likewise, we're told that the third angle is 3 times the first angle. If the first angle is x, then the third angle is 3x. And again, all angles in a triangle add up to 180. And at this point, all we do is have to solve this one algebraically for x, and we'll figure out what the measures of the first, second, and third angles are. So let's combine these like terms. X plus 2x is 3x. 3x plus 3x is 6x. So this is 6x equals 180. To get x by itself, we're going to divide both sides by 6. This crosses out, leaving you with x equals 180 over 6. This is actually pretty easy to do. 18 divided by 6 is 3, and just carry that 0 down. So 180 divided by 6 is 30 degrees. As we can see, x corresponds with angle 1. So we know angle 1 is 30 degrees. 2x corresponds with angle 2. So angle 2 equals 2x. We know x is 30 degrees, so let's plug that in place of x. So this is angle 2 equals 2 times 30. Therefore, angle 2 equals 2 times 30, which is 60 degrees. And similarly, we know angle 3 is 3x. So let's go ahead and do the same thing. Angle 3 is 3x. We know x is 30 degrees, so in place of x, let's put 30. This becomes angle 3 equals 3 times 30. 3 times 30 is 90. So now we have all the measures of the angles of this triangle, notably 30 degrees, 60 degrees, and 90 degrees, which is D. Okay, so again, the key to solving this one is knowing that all the angles inside a triangle add up to 180 degrees, and then you can use some basic algebra to solve this one. All right, number 21 says, if x is an odd integer, which of the following is an even integer? So the approach I take to these problems is I let x be a real value. It says if x is an odd integer. Well, let's let x be 3. We know 3 is odd. And if we let x be 3, we can plug it into all these answer choices. And once we find one that's odd, we'll know that's the correct one. So again, A says 2x plus 1. Again, we're going to let x be 3 since that's an odd integer. So this becomes 2 times 3 plus 1. 2 times 3 is 6 plus 1. 6 plus 1 is 7. 7 is odd. We're looking for an even integer in this case, so we know it's not A. Let's move on to B. Again, B is 2x minus 1. Again, we're going to let x be 3. So this becomes 2 times 3 minus 1. 2 times 3 is 6. Minus 1. 6 minus 1 is 5. Again, this 5 is an odd integer, so we know it's not this. Let's go ahead and do C now. C is x squared minus x. Again, we're going to let x equal 3. So this becomes 3 squared minus 3. 3 squared is 9. 9 minus 3 is 6. 6 is even. So C is the correct answer choice. Okay, so again, just assign x a real value. Again, it said x is odd, 3 is odd. Start plugging it into your answer choices until you get one that meets the stipulations in the question. Okay, so that's that one. All right, so number 22 says the sum of the first 7 prime numbers divided by 2 is. So to answer this one, we have to know the definition of a prime number. And that is any number that's only divisible by 1 in itself, and that excludes 1. Okay, so 1 is not a prime number. So let's go ahead and start with 2 then. 2 is only divisible by itself and 1, so that meets the definition of being prime. 3 is only divisible by 3 and 1, so that's prime as well. 4 is divisible by 4, 2, and 1, so it's not prime. 5 is only divisible by 5 and 1. 6 is divisible by 6, 3, 2, and 1, so it's not prime. 7's only divisible by 1 in itself. 8's divisible by 8, 4, and 2, and 1, so it's not prime. 9 is divisible by 9, 3, and 1, so it's not prime. 10 is divisible by 5, 2, and 1, so it's not prime. 11 is only divisible by 1 in itself. 12 is divisible by 12, 6, 4, 3, and 2, so it's not prime. And 13 is only divisible by 1 in itself. 14 is divisible by 7, 2, and 1, so it's not prime. 15 is divisible by 5, 3, and 1, so it's not prime. 16 is divisible by 8, 4, 2, and 1, so it's not prime. 17 is only divisible by 1 in itself. So these are our 7 prime numbers. There's 1, 2, 3, 4, 5, 6, 7 of them. And we want to know what the sum of them divided by 2 is. So let's go ahead and work on this. 2 plus 3 is 5. 5 plus 5 is 10. 10 plus 7 is 17. 17 plus 11 is 28. And I'm going to do these two since they're pretty easy. 13 and 17 is 30. So we have 28 and 30, which is 58. So this becomes 58 divided by 2. Again, you can regard fractions as long division by reading them like this. 58 divided by 2. Let's go ahead and work this out. 2 goes into 5 2 times without going over. 2 times 2 is 4. 5 minus 4 is 1. Drop down your 8. 2 goes into 18 9 times without going over. 2 times 9 is 18. 18 minus 18 is 0. So in other words, 2 goes into 58 29 times evenly. Therefore, we know the sum of the first 7 prime numbers divided by 2 is in fact 29. All right, number 23 says 10 to the negative third is equal to. As I mentioned in this video already, we can rewrite numbers that are written with negative exponents with that exponent as a positive exponent in the denominator. So in other words, 10 to the negative 3 is the same as 1 over 10 to the 3 with a positive exponent. And now we can just solve this one by doing some basic arithmetic. Again, 10 to the third is the same as 10 times 10 times 10. That is 10 by itself 3 times. So let's see what that is. 10 times 10 is 100. 100 times 10 is 1,000. Unfortunately, 1 over 1,000 isn't one of our answer choices, and so we have a few options as to how we can proceed. We can do this long division, which isn't too bad to do, or we can just look for one of these that has a 1 in the thousands place. So again, this is tens, hundreds place, so 1 is in the hundreds place right here. This is 10 hundredths, thousands, so 1 is in a thousands place right here. This is the same as 1 over 1,000. Now that said, let's say you took the approach of doing this long division. Let's see what that looks like. Again, we can regard fractions as long division by reading them like this. 1 divided by 1,000. And in this case, we would start by asking ourselves, how many times does 1,000 go into 1? It doesn't. So that would prompt us to put a decimal there and a 0 here. And I can write 1 with a decimal and however many zeros I want after it. Okay, so just bear in mind that 1 is the same as 1.0000 with however many decimals you need to do this long division. Now I'm asking myself, and I'm going to disregard this decimal because I'm going to go ahead and pull it up right here. Okay, now I'm asking myself, how many times does 1,000 go into 10? It doesn't. So I'm going to put a 0 there, and I'm going to add another 0 placeholder. How many times does 1,000 go into 100? It doesn't, so I have to bring another 0 up and another 0 placeholder. How many times does 1,000 go into 1,000? 1 time. 1,000 times 1 is 1,000, and 1,000 times minus 1,000 is 0. So this is the equivalent of 1 over 1,000, which we quickly identified was D. Okay, so again, you can either do the trick I showed you, or you can do the long division as long as you're good with long division. So that's that one. Number 24 says simplify. We have x minus 2 over x squared minus 6x plus 8. Again, this is another algebraic fraction. So let's go ahead and copy it down. We have x minus 2 in the numerator and x squared minus 6x plus 8 in the denominator. In order to simplify this algebraic fraction, it should be obvious that we're just going to factor its denominator and hope that that crosses out with what's in the numerator. So I'm just going to copy the numerator here. And this equation in the denominator, as we can see, is a quadratic that has a leading coefficient of 1. So we know it should be factorable like this. Now all we do is have to find two terms that multiply to positive 8, but add to negative 6. That's going to be minus 4 and minus 2. Again, negative 4 times negative 2 is positive 8, and negative 4 plus negative 2 is negative 6. Now we can simply cross out these x minus 2 terms, which will leave us with 1 over x minus 4. And we can't reduce this algebraic fraction any further. So the answer to this one is 1 over x minus 4. Okay, so that's that one. All right, so number 25 says, what is the sum of the numbers from 1 to 100? Okay, so this is a pretty challenging problem despite the fact that it's only a few words long. We want to find the sum of the numbers from 1 to 100. Again, the best way to approach these problems is to treat the terms from 1 to 100 as an arithmetic sequence. So for example, we have in this sequence 1, 2, 3, 4, 5, all the way to the last term in our sequence, notably 100. You know you're dealing with an arithmetic sequence when the common difference, that is the amount it takes to go from term to term in the sequence, is the same. So to go from 1 to 2, you add 1. To go from 2 to 3, you add 1. 3 to 4, you add 1. So we know this is an arithmetic sequence. And if you're working with an arithmetic sequence and you're given the first term and the last term, you can quickly sum the terms by using this formula. Sum of the number of terms equals the number of terms times the first term, which I'm going to call A1, plus the last term, which I'm going to call AN, all over 2. Let's identify what we have here. Again, from 1 to 100, there are 100 terms. So we're going to let n equal 100. So here and here, n is going to be 100. That means a to the n is also 100. Okay, so you might be saying, what is a to the 1? Well, a to the 1 is the first term in the sequence. So this is a to the 1. That makes this a to the 2. That makes this a to the 3, a to the 4. And this is a to the n, which we also know is a to the 100. Okay, so we have our a to the 1 and we have our a to the n, or 100. Let's plug them into this formula and solve, and we'll have the sum of the terms from 1 to 100. So this is sum of the first 100 terms equals 100 times the first term, which is 1, plus the last term, which is 100, divided by 2. Let's keep working this out. Sum of the first 100 terms equals 100. And this becomes 1 plus 100, which is 101 divided by 2. I'm going to work that out for you in case you can't do it mentally. 101 divided by 2. 2 goes into 1, it doesn't. 2 goes into 10. 5 times without going over. 2 times 5 is 10. 10 minus 10 is 0, but we got to drop down this 1. 2 doesn't go into 1, so we have to add a 0 here. And in doing so, we bring up a 0 here as well as a decimal. 2 goes into 10. 5 times, given that 5 times 2 is 10, so we can see there's no remainder. So in other words, 101 divided by 2 is 50.5. So this is s to the 100 equals 100 times 50.5. You don't have to work this out the long way, because anything times a power of 10 simply prompts you to move the decimal place in this number. So again, a power of 10 is 10, 100, 1000, and so on. So specifically, we're going to take this decimal in 50.5 and shift it to the right by how many zeros there are in this power of 10. In 100, there are 1, 2 zeros. So that's going to prompt me to take this decimal in 50.5 and move it 2 decimal places to the right and add a 0 placeholder as necessary. So in other words, s to the 100 equals 50, 50. So the sum of the first 100 terms is 50, 50, which is E. You shouldn't expect to see a problem like this, although there's a very slim chance you might see it. Again, if you're good with sequences, this won't be too difficult. But that said, I just threw this one in there to make this video a little interesting for me. And on that note, that's all I have for you today. I hope you found this video helpful. It takes a lot of effort to work out these problems. Again, I have to write the questions, work out the questions, edit the video, and then upload the video, including putting the links to my reference videos in the description of this video. So if you at all found this video helpful, please consider subscribing to my channel or leaving some nice feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose.
こんにちは。